Now, since our geometry part is completed, what I was telling about with the small this small window is, so just to mesh it, you can see we have the meshing option here also. But if you want the meshing to be separate, you can click on here. Then you can drag this geometry over here in this geometry. Then you can open the mesh from here also. Both are same. Okay, don't be worried that. And so also there are two kind of meshing are there. One mesh is this default mesh, ANSYS mesh we can say, or also there is also one fluent mesh. Yeah, fluent meshing. Okay, so there is also one fluent with fluent meshing. This is a different separate thing, so we'll it let me just forget it for the time being. Now we'll to click on this. First of all, save the project. Okay, now save project. It is coming like this. Just wait, ready. Okay, so you can see green button is showing, green circle is showing. So now you can go to the mesh, double click it and wait for it to open. Once you double click, see starting meshing and it is turned red. Okay, now wait till it is open. By default, I'm using the dark mode on ANSYS. While you will be installing this, you can see you will get an option for the dark mode or light mode. That's your choice completely to which option you want to choose. Then go, if you see here, you have the geometry import, that is import from the our design model or space claim. Then here you have a surface. If you click on it, you can see that it is popping green. So it is selected right now. Material has not been given yet. Okay, so then coordinate system, it is by default global coordinate system, that is this one. If you are using some different coordinate system, say suppose you want a new coordinate system at the middle, you can create it as well. Then it will be one more option over here, and there is a meshing and there is a name selection. So in the meshing, what you do, you create the different you divide your section in different parts, so that is called meshing. So there are two types of meshing, I would say. So there are basically two types of meshing. One mesh is called, let me change this to red. Okay, one is structured mesh. The second one is called unstructured mesh. Okay, structured meshes, as the name is suggesting, the structured is, suppose this is your domain can be anything. If your mesh is okay, so in meshing, what are the two things you have to see? This is called element. Okay, and these are called nodes. Okay, like in triangle case, this is called nodes, nodes, and this is called element. Okay, so if you see your meshing to be have a regular pattern, that pattern can be square, that can be a rectangle. Okay, so those comes under structured mesh, this the first one. Okay, so in structured mesh also, it is also of two type. Number A is uniform, second is B is non uniform. Okay, so the uniform is what? Uniform is like uniform. I'll making two meshes over here, then you can easily distinguish which one is uniform, on what is uniform and what is non-uniform. Okay, like this. So it can be like this also. Don't get confused that uniform will always be a square. It can be rectangle. Okay, but the rectangle should be of same size like this. Okay, but the non-uniform is what? Non-uniform is like this. Suppose you have something like this, something like this. Non-uniform like this. Can you distinguish it? This is what we call non-uniform. Okay, so it can also be non-uniform. Non-uniformity can be in any direction. It's not like that it's always in this direction, it can be in this direction also, like this. It is, this distance is keep on increasing. Okay, like this. So this is called non these comes under structured mesh. So structured two type, uniform and non-uniform. Then come to unstructured. Okay, unstructured comes under like you have a model like this, and you have a meshing which involves rectangle as well as other shapes also. Like other shapes, it can be triangular, it can be polygon. Okay, so like this, I'm just making some random mesh. Okay, you will see something like this. You'll see in the different see, now this also, this have rectangular at some places, and you can see the polygon are at some places, triangular, these are triangular. So many things are different shape. Apart from this rectangle, there are multiple other shapes also. This diagram, from here you can see that there is a tetrahedron mesh in 3D. If we talk about 3D, these are tetrahedron, this is called hexahedron, this is structured kind of thing, this is a prism. So these are the unstructured. Only structured one is shown by this hexahedron. Okay, this is polyhedral, pyramid. So these are the non-structured type. Okay, and this is called cell volume, this is cell surface, cell lines and vertices, which are called nodes also. So there are different type of mesh we can create. But if the geometry is simple, see that we know the what the geometry is. So if you see that there is some complexity in the geometry, like for example, I'm just taking the example of suppose a knife. Okay, so you are making a knife. Knife shape is something like this. Okay, for example, it is something like this. So your attempt, your try should be, you should try to make the mesh structured, always structured as far as possible. It is do make the structured. And okay, so don't if you think that it is not possible to make you structured, then go for unstructured. Like for here also, just see that this case. See here, if I try to zoom it, you can see it's a some random corner. You cannot make a rectangle over here, so it will be unstructured over at some point. Okay, what in this case, what I'll do, I'll try to make it in a two component where I can make a structured mesh. Okay, in this part I will be making unstructured. Unstructured I don't want, but I have to make because of this one. So if your geometry is complex, then in that case you go for the unstructured mesh, or possibly try to go for structured only. Okay, so I guess this one would be sufficient at this point. Okay, so now let us go back. I think there will be some background noise also. uh, yeah, going to mesh also. So if you right click on it, you will get an option for generate mesh or update, whatever you want to click, just click. See what type of mesh it is creating. Okay, then you will see it's a structured mesh with very coarse. Mesh can be fine and mesh can be coarse. Okay, so these are this is very simple geometry, simple one. So I'll be going very basic one, basic mesh also. So you can see here there are number of nodes and elements are there, which you can count it from. If you click on this mesh, you can go to statistics. You can see there are 63 nodes and 40 elements are there. Okay, so if you want to make it more fine, that is our obviously our aim. So you can right click on it. Once you right click on, when click on mesh, then right click, go to insert. Then there are multiple options: method, sizing, refinement, face meshing, inflation. So as far as for the beginning case, few methods will be important. One is method, sizing, then face meshing, then inflation. These are the basic methods. Then you can try doing this. So one method is this. Second is click on it, click on this, then right click, insert, then so many options are there. Okay, this is for if you have multiple parts. Then if you want to do kind of meshing in multiple parts, then you can individually select those. Okay, and also in the mesh section also you can see there are multiple options. Which is commonly used is one is this one. This is selection of vertex, which is not useful at all. Second is edge. If you click on it, you can select the edge. You can see I can select the edge. If you click on this face, I can select the whole face. Body, the whole body. Okay, so these things we will explore later on. So for the time being, I'll click right clicking on it. I'm going for sizing. Once you click on it, it is asking for geometry. Okay, so just before going, let me delete it first. First of all, if you see click on mesh, you will see different options. Okay, so make sure that you are going for fluent, so you have mechanical CFD selected. Okay, then in CFD you select the fluent. Okay, not CFX and polyflow. Okay, then element sizes. So whatever meshing, if you click on this mesh and whatever changes you make over here, that will be a global changes. Global means whatever change you are making here, it will be made in every part. Okay, for what I mean is that suppose my part, I have created such a part which are having multiple bodies connected over here. Okay, suppose there are four bodies. So if I will be making any changes in this after clicking on this, if I'm making changes here also here, then the change will be made in every domain, in every section, here, in here, and every here. Okay, but if you want to make, suppose I want to make more fine mesh in this area but coarse here, because this is not our region of interest. If I want to make fine here and here, then it will be locally controlled. Okay, that I'll tell you later how you do this. So if you, by default the element size is 12.5. Just first of all make sure that the unit you are using it is mm. Okay, from where to go and change the unit. I'm okay, unit, it's a new ANSYS version, so I'm a little bit confused also. So here you can go. Okay, that we'll do later on. Okay. Yes, yes, okay. Yeah, here, unit. Make sure that you are selected mm. Okay, don't select the meter, because by default our design things is under the mm. Okay, yes, once you click on it, by default size is 12.54. If you click on it, just simply press 5, some random value, then you will see the green bar here, green symbol. Right click on it, update or generate whatever you want. See, it is now more fine. Now you can see the nodes and elements are this much. Now if you try to make it more fine, you can click one. You can either you can generate from here, or you can simply click here also. You can see the meshing is being done here. Okay, so you can see the more fine, but everything is structured. Okay, so if you want to make local controls, in this one there's not other parts, but if you want to make local changes, then you can click on it, right click on it, then you can do a sizing. For the timing and going with the size, by default it is being selected body sizing, because there is face and body are same, it's a 2D one, so body sizing is selected. But suppose I click on this, I selected this edge, then click on it, then insert, then sizing, it will be edge sizing. Got it? By default it is edge sizing, because I have selected the edge before. Okay, so if you don't want to do this, you can just delete it. Then if you just click on it, sizing, then it is asking for geometry. So if you have selected edge, it will be edge sizing. You have to click on it, you have to click apply here, it will be edge sizing. Okay, but by default if you selected face, it will be a face sizing. Okay, so you can give, if you suppose I'm doing face sizing, I have to give the element size. There are multiple option also. The element size is generally used. So what you can do, you can give, by default it is 1 mm, you can give is 0.5, then you can generate. Let's see what changes. Sometimes it happens that you do something and there you see there is no change. Okay, so it happens sometimes, you have to do, so this mesh is nothing but a no, I will not say it's a hit and trial, but sometime it is hit and trial. You are not exactly sure what will exactly happen. See, I have taken a face size to be 0.5. I guess it is quite very less, quite low value, that's why it is taking more time. Okay, so now I guess you can see here, you can see for more fine mesh is created. It is square in shape, that's fine. Structured is all what we want. Okay, so for the timing I'm making it again 1.5 and going for update. Okay, so now again you can see it is now if I want to, suppose I want to make mesh to be having more number of element here in this edge. Okay, what I want to say is that just see sizing, and if you click on this, if I click on it, it will be edge sizing. Now it is asking for element size. Here the two things are used, element size and number of divisions. Suppose if I click on it, it is asking for me number of division. You can say right now it is 1, and by default you can see the one yellow bar. So if you increase this one, suppose say 20, or I would say 25, click outside, you can see the 25, it has been divided into 25. Okay, now you generate this. Now so, okay, I guess you can see the 25 here, but the effect is not shown up to this point. So while selecting this edge sizing, I should select this edge also. Let's see what will happen. It's generated. This one is a very simple one, so it will not be required to this extent. Okay, so you can see here so many things have been done here. So to let's try with the face meshing. What happens with if we do the face meshing? Now you can see with the face meshing those irregularities. So you see, if I don't want to use, suppose face meshing, then right click it, suppress it, then it will suppress. Now again click generate. Now see, did you see the what changes exactly happened? See, there are some triangular meshes also, that is called unstructured. These are the unstructured at these point. Okay, but I don't want this because it's a simple geometry and I can easily make the required changes in this. Okay, so if you see these kind of irregularities, the face meshing is used to make the mesh a little bit better. Okay, now if I increase the edge sizing to suppose 50 and again generate it, you can see the differences. Now see the difference. There are 50 number of. Now see, they are here. You can, so you don't see this the irregularities in between. So it may be possible if you are using some different version of ANSYS. If you are following the same method, same techniques, you may see there are irregularities. So it changes with the ANSYS version to version. Okay, but there are definitely some irregularities which we actually don't want. Okay, so what you can do, we can do face matching. Right click on it, unsuppress, generate. Okay, can you see this? Okay, here it is non-uniform over here and uniform in between. That is perfectly fine, there's no issue in that. Okay, now suppose you want and also there is a, in edge sizing there are other some types also, which is called bias type. Right now it is not bias. Bias means if I click on it, no bias means it is uniformly distributed at every point. You can see uniformly distributed. But if I click on it and select the bias, there are multiple type of biasnesses there. If I right click on it, it is saying define the bias factor. Suppose bias factor is 2, bias factor is 3, make it 4 to easily visualize. Can you see? Can you see it is thicker over here and very smaller over here. Can you see the difference? If you click on it, see, it is thicker on this side and thinner in this side. Again, there are multiple options also. Thicker outside, thinner inside. If I select this one, then go to generate. Okay, can you see? It is thicker outside and thinner inside. So these are the things that we can actually perform. So I'll be leaving it till this point. See, that depends which type to use, that depends on application. Okay, so don't be like there's no universal rule that this will be used every time. No, depends on application. We can select the mesh. Okay, now if I want to make if I'm not happy with the number of element over here. Okay, so what I can do, I want to increase the element size over here. I can click here, I can click here. Let's see what if we click on here, then we can go for sizing. It by default it is sizing. So give number of division, suppose I give 250 number of divisions, then generate. The video can be little bit longer, but it will be useful. Okay, now you can see over here it is not tilted at some angle, but what we did, that we selected only one edge. Let's select other edge also. What we have to do, to do this, we can simply select edge sizing, go to geometry, click on plus control, click on this also. You will see there are two edges not being selected. Okay, now click on generate. Now you can see mesh is created like this. Now you can see there are 13,000 nodes and 12,700 elements. Okay, so actually I don't want this. Okay, let's make it very simple and let it be whatever have been created. We can later on decide. You can later on make any changes. Okay, now you can make it more fine by giving edge sizing also. Sorry, the body sizing. Click right, select this body, then click on it, then right click, insert sizing. Then element size you can give by default it is 1 mm. I can give it 0.75. I'm just trying to make it more fine. That's it. Nothing else. You can see it is more fine. No, it nothing, no changes have been made. Okay, so let's go for a little bit more fine. That's what I told you. You may be thinking that after doing this should happen, but it may happen, it may not happen sometimes. Okay, I guess because we applied the face meshing, that's why it is happening like this. So I guess if I suppress it, you have to check it time and again that what is actually happening with what I'm doing. See, now after removing face meshing, this has been done. Okay, so if I just simply remove it, I don't need it actually over here. So I guess just simply suppress it, generate. I'm going to, once we will doing the other problem, you will, then we will explore more options. Okay. Okay, now face meshing is important because of this irregularity. If I turn this face meshing on, I guess this irregularities will be no longer. Okay, yeah, you can see. Again, if let's try for 0.5, if I don't think there will be. Okay, element size by default is 0.1. If I make it 0.5, okay, 4,000. Why is it 4,000? Because I've removed this edge sizing. Because of that, let's see if I make it 0.2, generate. No changes being made. No changes coming out. You can click on it and you can make global changes. Make it 0.5. See now there are some warning as well. Some local faces element size are larger than the global maximum size. This may cause bad quality elements. Okay, let it be for the timing. Okay, so so to check our mesh whether it is good or bad or fine, we can, there are multiple parameters we can see here from advanced option, or from which option, quality. From quality, if you say check uh, from where do we, yes, mesh metrics. There are multiple options. Out of these, few things are actually of our use. One is orthogonal quality. Orthogonal quality, if you can see, the orthogonal qualities should be such that it should be closer to 1. Okay, in this case, since it's a perfectly rectangular mesh, we can say, so the average is still 1. So in our other geometries, this average value should be close to 1, but should be 0.8, 0.9, it is fine. Okay, the other quality, other method, other this is skewness. Skewness should be as close as possible to 0. In this case, it is 0.00025 average value, it is fine. But it should not be like 0. Average value should not be like 0.4, 0.5. It will throw some error in your Fluent setup. Okay, so this skewness is there. Then aspect ratio we can also check. Okay, it's a good, there's no issue. You can see there are rectangle, there's square, different ratios there. That is why you are getting 2.222. Okay, that is fine, there's no issue in that. But uh, if your mesh is somewhere is triangle or polyhedral, some kind of that kind of mesh, then it will be more distorted. The skewness will be high. In this case, it is okay. We can make the perfect square shape also. There's no issue in that. But for the time being, just for the beginning, we can do this, and later on we can optimize it better. I am not saying that this is a best mesh, but it is fine for the beginners. Okay, now going to you can see the name selection. Earlier we did the name selection, the space claim over here in the groups, but that you can do if you forget to do that over here, you can do these here as well. Okay, how you'll do, you can do this, you can just simply select it, edge, then click this, right click, create name selection. Okay, here you can give it name outlet, inlet and walls. Okay, and also you can name it as here and then right click fluid domain. Okay, so now our domain is ready. Everything is, this is what you have to do. Okay, see, mesh is it's in itself is a very huge topic, and it's not the easiest task, and this is actually the most important task in any kind of simulation, because if there is some kind of error in the mesh, it will throw error in the simulation, and that you have to interpret that where exactly the error is coming, what type of error is coming. So many different things you have to do in ANSYS. Okay, so let's now jump to the Fluent.